once again to Program Arjun, and today I am here with my second lecture of the topic Rational and Irrational Number for class 9th Mathematics. Let us start. Dear students, after the first lecture, it must be clear to you what are rational number, what are irrational numbers, and how do we plot them on the number line. Now students, the next biggest question in rational and irrational number is, how can we identify whether the given number is a rational number or an irrational number? So students, to do that, first of all, let us recapitulate once again the definition of rational number. As you can see on the board, any number which can be represented in the form p upon q, where p and q are integers, q is not equal to 0 and p and q are co-primes, is called a rational number. Let me elaborate the definition for you. A number should be in the form p by q. That means it should be in the fractional form. It should have a numerator as well as a denominator. P stands for the numerator and q stands for the denominator. Next, both the numerator and denominator should be integers and the denominator should not be equal to 0. And the most importantly, the last part of the definition is very important, that p and q are co-primes. Co-prime numbers means those numbers which have no common factor other than 1. That means both the numbers are having only one common factor, that is 1, or in other words you can say both the number are in their lowest terms. Students, for example, if I take a number, as you can see on the board, I am writing it here. If I take a number 4 upon 6, here you can say, sir, it is in the fractional form where p is equal to 4 and q is equal to 6. P is equal to 4 and q is equal to 6. But students, you can see both p and q have a factor 2 common other than 1. That means they are not co-primes. So they are not in their lowest terms. So if we divide both the numbers by 2, it becomes 2 upon 3. And the number is in its lowest form, and that is 2 upon 3. And now it can be called an rational number. Students, I hope you must have understood the definition. Now, to further understand the things, let us take some numbers. So, you can see on the board, students, there are certain numbers which we will use to understand how can we identify number as rational or irrational. First of all, students, you can see the number on the board 2 upon 3. It is in the fractional form where p is equal to 2 and q is equal to 3. So students, you can see both the p and q are integers. Q, that is 3, is not equal to 0 and both 2 and 3 are co-primes. Hence, they satisfy all the norms of the definition and hence it is a rational number. The next number, students, 4 upon 9. Again, p is equal to 4, q is equal to 9. Both are integers. 9 is not equal to 0 and 4 and 9 are co-primes. That means they don't have any other factor than 1 common in them. So they are rational numbers. That means that is the number is a rational number. The next number that you can see is an integer, that is 1. Now some of you may say that there is no q in this number, but students, all of you know that any integer can always be written as 1 upon 1, 2 upon 1, 3 upon 1. That means we can always use 1 in the denominator and hence it is also an rational number. The fourth number, students, 0 upon 1. Here p is equal to 0 and q is equal to 1. Both are integers and you can see that p is 0 but q is 1. The condition is that q cannot be equal to 0 but p can be equal to 0. So definitely 0 upon 1 where q is equal to 1 and both are co-primes is a rational number. So students, you can say all these four numbers which are there, 2 upon 3, 4 upon 9, 1 and 0 upon 1 are rational numbers. Now students, we are left with some numbers which are under their square roots. Now if the numbers are in their square root or in their cube roots, there's a different way to understand whether the numbers. So students, if the numbers are in their square roots or in their cube roots, then the working formula to understand whether they are rational or irrational is, see the number which is there under the square root or the cube root. If the number is a perfect square and it is under a square root, it's a rational number. Whereas if the number is not a perfect square and it is under a square root, it is an irrational number. With the example we can understand. The first number that you can see is root 2. So obviously students, root 2 you can see. Root 2, we have a number 2 under the square root. 2 is not a perfect square. So root 2 is an irrational number. Whereas root 4, 4 is a perfect square number. Perfect square number means whose square root is always a whole number. The square root of 4 is 2. So 4 is a perfect square number and it lies under a square root. So it will be a rational number. Similarly, we can extend the definition to cube roots. If we have a perfect cube under a cube root, then it is a rational number. And if we don't have a perfect cube under a cube root, it's an irrational number. For example, you can take the third number, that is cube root of 8. Cube root of 8, you can see the number under cube root is 8. 8 is a perfect cube and hence it is a rational number. Whereas cube root of 4, you can see students, cube root of 4 is not a rational number because 4 is not a perfect cube. So students, the working formula once again I will let you know. If there are numbers in the roots, under the roots, then we have to see whether the number is a perfect square or not, perfect cube or not. If a number is a perfect square and it lies under a root, square root, it's a rational number. If the number is not a perfect square and it lies under a square root, it's an irrational number. Similarly, if a number is a perfect cube and it lies under a cube root, it is an rational number. And if a number is not a perfect cube and it lies under a cube root, it's an irrational number. Now students, the next way out to represent the numbers is decimals. And let us find out how in case of decimals we will identify whether the given number is a rational number or an irrational number. Students, you can see I have taken a flow chart here. Decimals basically are of two types, as you all know, terminating and non-terminating decimal. Terminating decimals are those decimals. Terminating decimals, you can see students, these are those decimals which end up. Like the example which is being given is 2.25. That means the decimal ends at 2.25. 5 is the last digit of the decimal, so it's a terminating decimal. Whereas non-terminating decimals are further of two types. One is repeating decimal, another one is non-repeating decimal. Students, you can see in repeating decimal, the example you can see is 3.33333 and so on. That means the decimal is not terminating. That means continuing. It will never terminate. But the place 3 is repeating itself. So it's a non-terminating repeating decimal. I think it is clear to you. Next one, you can see the example 5.01, and so on. That means the number does not terminate. So it's a non-terminating decimal, as well as it does not repeat also. That means there is no pattern which is being followed in the number. So obviously students, you can say that it is a non-terminating, non-repeating decimal. So basically I can say decimals are of three types. The first one is terminating. The second one is non-terminating repeating, and the third one is non-terminating non-repeating. Out of students, these two, terminating and repeating decimals, are rational numbers because they can be written in the form P upon Q. This you have studied in your previous classes. But the number which are non-terminating and non-repeating, they cannot be represented in the form P by Q, and that's why they are irrational numbers. What are they? They are irrational numbers. So students, in decimals, terminating decimals and repeating decimals are rational, whereas a non-terminating, non-repeating decimal is an irrational number. So if the numbers are in decimal form, it's very easy to understand whether they are rational or irrational. Now students, I hope you all have understood what are rational numbers, what are irrational numbers, and how can we identify whether a given number is a rational or an irrational number. Now let us solve certain questions. It's time to solve certain questions based on the definition of rational and irrational numbers. And the first and the second lecture that you have already studied, or the things that you have studied in the first lecture and this second lecture, based on this we will solve certain questions. I will be solving here 3 questions of different types, and based on these types you can solve a lot more questions from your textbook. And if you have any queries regarding those questions while you are solving, must post your query in your WhatsApp group so that I can answer it as fast as possible. So students, let's begin. You can see the first question here. Students, the first question is insert a rational number between 2 by 9 and 3 by 8. You can clearly see it on your board. 2 by 9 and 3 by 8, we have to insert one rational number. Now students, when we have to insert one rational number, it is very easy. What we have to do is that we have to add up both the fractions and divide it by 2, and we will get a number which lies between these two rational numbers. Now let us see. The two numbers that we are being given are 2 by 9 and 3 by 8. You can see. And what we have to do, we have to find out one rational number between 2 by 9 and 3 by 8. So students, you can see here 2 by 9 plus 3 by 8 whole divided by 2. As I said to you, after the calculation, it becomes 43 upon 144. So 43 upon 144 is the number which lies between 2 by 9 and 3 by 8. So we have got the rational number between two given rational numbers. The second part of the question was arrange them in descending order. So students, first of all, we have to compare both the rational numbers which are being given to us. You can see 2 by 9 and 3 by 8. You know the rule how to find out which one is smaller, which one is greater. Just cross multiply it. 2 into 8 becomes 16 and 3 into 9 becomes 27. So obviously 3 upon 8 is greater than 2 by 9, and hence when we arrange them in descending order, that means bigger to smaller, 3 by 8 comes first, then comes 43 upon 144, and then comes 2 upon 9. So students, in this question, you have learned how to find out one single number between two given rational numbers. Very easy process. Only what you have to do, you have to add up both the fractions and divide the addition of the fraction by 2. I hope you have understood. Let us move on to the next question. Students, here we are there with our second question, and as you can see on the board is find out 5 rational numbers between 3 upon 5 and 4 upon 5. The numbers you can check 3 upon 5 and 4 upon 5. 3 upon 5 and 4 upon 5. But the problem is we don't have to introduce one rational number in between them, but we have to find out 5. Now, we can find out any number of rational numbers between two given rational numbers, and the process is very easy. First of all, what we have to do is that we have to see that both the given fractions, here the given fractions you can see is 3 upon 5 and 4 upon 5. Whether they are like fractions or not. Now students, I hope you know what are like fractions. Like fractions are those fractions where denominators are same. And if they are not in their like fractions, then you have to convert them in the like fractions. Like suppose if you are given a number 2 upon 9 and another number is 2 upon 4. So you have to convert them in like fraction. 2 upon 9, that means we have to make this 9 and 4 in equal denominators. So LCM of 9 and 4 will be 36. So what we have to do, or we can take 18. So what we will do is that we will convert both of them in 36 or 18. If we convert them in 18, it becomes 4 upon 18. I hope I made a mistake. 9 and 4. Okay, 4 upon 18 and 2 upon 4 becomes 1 upon 2. So it becomes 18, 9 upon 18. So students, so you can see here that the numbers which were being given 2 upon 9 and 2 upon 4 or 1 upon 2, both were not like fractions, but we have converted them in like fractions. Now students, you can see that here the numbers which are being given 3 upon 5 and 4 upon 5, they are in like fractions. So what we have to do is that we have to simply move to the point or to the trick by which we can find out 5 rational numbers in between them. Now we have to find out 5 rational numbers. That means basically we have to multiply both the fractions by 5 plus 1, 6. Suppose if it is being said find out 7 rational numbers, then what we have to do? we have to multiply both the fractions by 7 plus 1, and that is equal to 8. But here we are being said to introduce 5 rational numbers, so 5 plus 1, 6. Now 3 upon 5 when multiplied by 6, it becomes 18 upon 30. As you can check, it becomes 18 upon 30, and the next number becomes 24 upon 30. Now both are in like decimals or like fractions, and both have the denominator same as 30, and you can see there are lot numbers between 18 and 24. So you have to find out 5 numbers between 18 and 24, and those numbers are 19, 20, 21, 22, 23 and 24. So students, the fractions in between 18 by 30, that is 3 by 5, and 24 by 30, that is 4 by 5, are 19 upon 30, then 20 upon 30, 21 upon 30, 22 upon 30 and 23 upon 30. You can also reduce them in their lowest terms. That means 3 upon 5, 19 upon 30, 2 upon 3, 7 upon 10, 11 upon 15, 23 upon 30 and 24 upon 30. So students, in this way you can very easily get 5 numbers lying between 2 given rational numbers. I hope you have understood the question and practice some more questions on this topic or of this type. Now let us move on to the third important question of this chapter, and the third question is, prove that root 5 is an irrational number. Students, you already know that if a number is not a perfect square and it is lying under a square root, so it will be an irrational number. Students, you can see 5 is not a perfect square, it is lying under a square root, so it will be an irrational number. But how can we prove that? The question is, how can we prove that? So these type of proofs are called proof by contradiction. That means in these type of proofs, if I have to prove that root 5 is an irrational number, first of all I will assume that it's a rational number, and then at the end of the question I will show that my assumption was wrong, and hence it will be an irrational number. So what we will do is that, you can check on the board. Let us assume that root 5 is a rational number. So if it is a rational number, then it will be in the form P upon Q. So you can see root 5 is equal to P upon Q. Root 5 is equal to P upon Q. And if root 5 is equal to P upon Q, square on both the sides. And if you square on both the sides, it becomes root 5 becomes 5 and it becomes P square by Q square. So if you cross multiply, P square becomes equal to 5Q square. That means this Q square is, which is multiplied by 5, is also divisible by 5. 5Q square is divisible by 5. And if P square is equal to 5Q square, that means P square is also divisible by 5. If P square is divisible by 5, then P is also divisible by 5. That means 5 is a factor of P. This is my first point, that 5 is a factor of P. Now if 5 is a factor of P, then P is a multiple of 5, and P can be written as 5M. P can be written as 5M. Now where M is any integer. Now we will substitute this value P is equal to 5M in the given equation. P square is equal to 5Q square. So in place of P square, we will write 5M square is equal to 5Q square. If we square it, it becomes 25M square is equal to 5Q square. That means 5M square is equal to Q square. Now from this point again we can understand, students, that Q square is a multiple of 5, or 5 is a factor of Q square. If 5 is a factor of Q square, then 5 is also a factor of Q. So this is my second point. In the first point we have proved that 5 is a factor of P, and the second point we have proved 5 is a factor of Q. So from first and second point we can say that P and Q have a common factor 5, and this contradicts our assumption that P and Q don't have any common factor. That means they are co-primes. So in the beginning we have assumed that they are co-primes, but now we can see that they are not co-primes. So you can say that assumption that we have made, that assumption was wrong, and hence root 5 will be not a rational number, it will be an irrational number. Students, if you have any confusion in this question, you can tell me on your WhatsApp group. I will definitely explain this question again for you in some different way, but it's a very easy one. You go through the method, you go through the lecture once or twice, you will definitely understand This is the method which is called proof by contradiction. So students, with this question, the second lecture on rational and irrational number comes to an end. I hope you have understood the lecture, you have enjoyed it. Now it's time to study. It's time to open your textbook, solve certain questions on the basis of these given questions, and wait for the next lecture. Okay students, thank you so much. See you. Bye bye.